RPV adoption analysis approach is developed to facilitate the analysis. Normally, researchers apply different behavioral theories to explain the adoption decisions, such as theory of planned behavior. Researchers collected and processed data from the survey to get the findings. Due to the structured data format and complexity in behavior-based raw data, normally nonlinear estimation procedures are required to process the collected data. However, the existing conventional statistic analytics approach cannot process the nonlinear relationships in the raw data, such as linear regressions and SEM. Both of them require the strong linear assumption on raw data. On the other hand, ANs have the impressive generalization capability and can process nonlinear data, but it suffers the black box problem, which is not able to explain and identify the driving factor. This leads to few research applying ANs in RPV adoption analysis. Therefore, the research question is raised: how can ANs be used to explain the nonlinear relationship among behavior factors in RPV adoption analysis? In summary, this research aims to investigate the mechanism of RPV adoption considering the consumer's nonlinear adoption behaviors. To achieve this goal, two research objectives are raised. Firstly, to propose an AN-based analytic procedure for forecasting and explaining RPV adoption by integrating the behavior theories and the factors important calculation approach. Secondly, to identify the driving factors in RPV adoption, considering consumers' nonlinear adoption behaviors using the proposed AN-based analytic procedure. This slide shows the research methodology of our study. Firstly, the behavior theory is chosen as the fundamental theories to guide the survey collection and hybrid AN modeling. We select TPP as our best theory because TPP provides a powerful behavior analytic framework with three hierarchy structure, which is easy to be implemented to build AN model. Secondly, the corresponding survey questions are designed and distributed among residents in Singapore. The raw data is separated into training dataset and test dataset. Thirdly, by using the TPP structure to construct AN model, the hybrid TPP-based AN decision-making model is built. Firstly, the built model needs raw data to train and validate. After validation, the hybrid TPP-based AN model can be used to forecast the adoption decisions and identify the driving factors via connection weight approach. The performance of the proposed model has been tested and compared with two conventional data analytics approach, linear regression LR and multi-layer perceptions MLP. LR is chosen to show the capability of processing nonlinear relationship in raw data, and MLP is one of the classic AN model, which did not contain the TPP information. MLP is chosen to show that the integrating of TPP structure indeed helps increase the model's forecast capability. The table shows the result of forecast performance of the testing model for the 5 label classification problems across 10-fold validations. The result confirms that nonlinear processing capability and the superiority of TPP structure in building AN model because the proposed model outperformed the other two models with higher performance accuracy. In order to validate the significance of identified factors by the proposed model, SEM was implemented to do the cross-validation. After conducting a series of data checking and data cleaning, SEM identified the attitude and subject norms are two significant components impacting the intention of RPV adoption directly, which is consistent with the findings from the proposed model. What is more, the proposed model further identified the importance of the specific factors in different adoption intention groups. Readers can rank the factors' importance based on the calculated values, while the SEM cannot provide. In conclusion, the study addresses the nonlinear relationship in RPV adoption analysis by proposing a TPP integrated AN model cooperated with connection weight approach. By implementing the proposed model in the case study of the RPV adoption in Singapore, The results confirm that TPP-AN outperformed the ALR and MLP. In addition, the identified driving factors are consistent with the SEM result. This study found the consumer's attitude towards environmental and economic benefits brought by RPV and residents' obligation to install RPV significantly influenced the household intention of installing RPV. Also, this research summarized some insightful policy implications for RPV adoption in Singapore. For example, broadcasting the RPV through the mass media and social media because residents' awareness to RPV is found to be low, stressing the residents' social obligation by connecting the RPV with the consequence of global warming. This study contributed to both methodological and practical. Methodologically, this study innovatively combines the behavior theories with ANs to process the nonlinear relationships in consumers' adoption analysis. Practically, the proposed hybrid AN model can be easily applied to analyze the adoption of other behavior-based renewable energy technology in different geographic locations. Thanks for your listening.
Hello, every participant. My name is Jerry Lai. Today, I'm pleased to have a presentation.
You're muted, Taha.
Yeah, thank you very much, Nan Zhang, for your presentation and sharing your research with us here. I open the floor to questions. Nan with us, is that right?
Yeah, I'm right. I'm here.
Yeah, I can see you. Yeah. Okay. Any questions, please, from the floor? I can kick off the questions. When you look at the difference in accuracy and performance between the artificial neural network models and the regression analysis models, I see from your results the difference is not that very big. Do you have any explanation, or do you think that the difference is statistically considerable?
Okay, thanks for your question. You raised a very important questions. And for this, actually, there are two possible reasons to cause this not very significant. The first one is that actually this data, survey data is only have 300. It's relatively a small data set for AI models to be trained and to be tested. And the second reason is that given this small data, and we split our problems into the 5 labels, 5 label classification problems, so that we can see the accuracy of the proposed model is around 16%. Yeah.
Oh, okay. Yeah, this is a good point. Yeah, thank you for it. Any more questions? I have another point. The factors which you use as input factors, the influencing factors for the mapping and forecasting the behavior. How about the sensitivity analysis? If you select or added other set of factors, or used additional factors, or change some of these factors, what do you think about the sensitivity of the model and the results?
Yeah.
Have you done? Okay. Yeah.
Yeah, I think you have mentioned what I'm going to do is that we are going to analyze the sensitivity of each factors, and also for the first step is that we currently can conclude the factors importance given our framework. Then the next step is that we want to collect more data with more dimensional factors to see is there any other factors that can contribute more to increase our model's accuracy. Yeah, so that's a very good suggestion. Is also what I'm trying to do next step.
Oh, that's great. That's great. So you will include the sensitivity analysis in the next phase of the research. Thank you very much for that as well. If there is no more questions, we can move to the next presentation, and we have a presentation on productivity of robotic excavators for the Kherson construction. So if we can have the video, please, Mohammed.
Yes, please also confirm when it's displaying correctly.
Okay. This is by...
My name is Jerry. Today I'm pleased to have a presentation. The title is Productivity of Robotic Excavators for Kherson Constructions. The paper ID is 61. Introduction. Kherson is actually a circular concrete pile constructed using manual method, so it is also called as hand-dug Kherson. It was a construction method invented in Hong Kong in about 1960s. The worker firstly dig the shaft for a depth of 900 millimeters to 1000 millimeters, and then he would cast the concrete ring to support the surrounding soil. The next day, the worker would repeat the step until reaching the required depth like this. So the productivity of excavation of hand-dug method is basically recorded as a range from 900 millimeters to 1000 millimeters per day. Our research team recently designed and manufactured a robotic excavator aiming for determined productivity benchmarks, reduce workers' safety and health hazards. The reducing hazard actually means that basically the worker needs to enter the shaft to do the excavation task. This confined environment imposes lots of safety and health problems to workers. So actually, this construction method is not a good method in terms of safety and health. That's the reason why our research team manufactured this robotic excavator. Later, I will show you a case study relating to the productivity performance of this robotic excavator. Research gap. Previous researchers have benchmarked productivity of some piling constructions. For example, productivity of piling process using questionnaires and expert interviews. Productivity index using simulation to quantify the impact of subjective factors on the process productivity of continuous freight auger piles. Regression to categorize the relationship between the productivity and critical factors for square precast concrete pile constructions. So our team would also like to benchmark the productivity of robotic excavator. So the methodology is presented here. First of all, our team designed and manufactured the excavator, and then we conduct a site trial to test the functionality. Then we conduct time measurement of excavation motion to record a cycle time. This recorded cycle time will be used for the simulation model to estimate the construction time of a Kherson. Finally, we conduct a case study to evaluate the competitiveness of this excavator against common piling construction method of ball pile. Our case study has two aims. The first is to benchmark the excavation productivity of the robotic excavator. The second one is to compare the productivity of shaft excavation between ball pile method and robotic dug method. Actually, the productivity of ball pile method for the case study is recorded from an ongoing building project in Hong Kong. The productivity is about 167 minutes per meter in depth. On the other hand, we try to obtain the productivity of robotic duct method in this way. Firstly, we carry out time measurement on individual excavation tasks from site trials. Together with, we developed a simulation model for other remaining tasks of caisson construction so as to obtain the overall productivity. As said before, the research team wants to benchmark the productivity of the robotic excavator. Before that, we shall firstly note that we adopted 45 meters as the basis because it is the maximum depth of caisson recorded in Hong Kong. After that, the simulation results are on this table, or in a step of 15 meters. As you can see, the deeper of the excavation depth, the longer excavation time. Certainly, it is true because it needs more time to transport the soil from the bottom to the ground. The total time of shaft excavation for a 45-meter deep caisson is 14,950 minutes, which is considered as the benchmark productivity. Next, this productivity may be used for further comparisons with the bore pile method. For the bore pile method, as I said before, the productivity is from an ongoing project. The result is the total time of shaft excavation of the bore pile method is 37,671 minutes for 5 numbers of 45-meter deep piles. Actually, the productivity of bore pile method is much better than the robotic one if we considered one set of resources only. However, the robotic method owns advantages of less working space and ease of mobilization comparing to the bore pile method. If this advantage is to be taken into account, that means more sets of resources may be utilized and excavations of multiple caissons can be done concurrently. The overall productivity of robotic method can be improved and even outperformed than the bore pile method as shown on this graph. Here is our conclusions. Firstly, our team has prototyped a robotic excavator to replace the manual excavation task of hand-dug caisson. We also benchmarked the productivity of caisson shaft excavation by the new robotic excavator using time study plus simulation method. The case study shows that the productivity of bore pile method is initially better than the robotic duct method if one set of resources is only considered. If more sets of resources are able to be adopted and multiple caissons could be excavated concurrently, the productivity of robotic method may be able to outperform than that of bore pile method as shown on the previous case study. That's all of the presentation. Thank you for your attention.
Yeah, thank you very much, Jerry Lee and Lam, Chan, Yam, and Lau. Thank you for the comparative study of productivity. And open the floor for any questions, please. Okay, I have a question for the when you said the resources are increased, the productivity changed. So at the beginning, the borehole method is more productive. But with more resources employed, the robotic is more productive. So can you explain what do you think the reasons behind that, please?
Yes, can you hear me?
Yes.
Oh, thank you. Thank you for your questions. That's a good question. So I would like to make this chance to expand a bit more about our case study. Okay. Actually, Hong Kong, maybe you have been there. It is a very crowded city. So the construction site in Hong Kong is, I should say, is relatively small compared to other foreign countries. And because Hong Kong needs more land to build a high-rise building, so as I said before, ball power method is more structurally higher performance method to be for the high-rise building. But to construct a ball power, it needs a heavy machine, heavy-duty piling equipment. It is quite occupied compared to a tiny or small construction site. But as I said before, a Keyshawn method is has an advantage of easier mobilization, because this method doesn't need very heavy-duty machine or heavy-duty piling equipment to construct a pile in the same diameter of ball pile methods. So we aim to, our research team aim to find out the competitiveness of this method, Keyshawn method. So we try to find a site relatively small to study the productivity. That's the direction we want to go to. For that site, this is only allowed to use one set of ball power machine to build the works. But we studied that we can put in the same site, in as the same size of the site, we can put maximally 3 sets of resources for the Keyshawn method. So that's why we take this as our case study to firstly figure out whether our method is competitive to the ball power method. May I answer your questions?
Yeah, thank you very much for elaborating on the case study and the reasons behind these differences. And how about if you want to take it further to compare the cost-benefit analysis here? So your focus on productivity, I appreciate that, but because you also touched upon other issues that the working space and the access to site, these kind of things, and which will constrain the resources you can use for each of the methods. So if you take that into consideration in this case, what would be your recommendation here, even if there are also these differences in productivity?
Yes, this is our first step to go through, and that's the point you raised is a good opinion. Actually, we would also study other factors that would affecting the productivity. Example for the access problem and that sort of stuff. We are going to study in the very short period of time.
Okay, thank you very much.
Thank you.
Any more points or comments? Then can we move to the next presentation? We are going to have Jasmine presenting on assessing the impact of smart technologies on project management, the case of Singapore. Jasmine dropped us an email this morning saying that she has got a health issue. We wish her well soon. But we are going to run the video, and if there are any points, we can discuss them as well. Thank you.
Good day to all of you. On behalf of the authors, I will be presenting on assessing the impact of smart technologies on project management, the case of Singapore. And this is what I'll be covering today. First, key technologies associated with the fourth industrial revolution, such as cyber-physical system and Internet of Things. They can self-organize and execute work tasks, enabling the integration, digitalization, and automation of entire value chains. So these smart technologies, they allow work processes to be optimized according to the conditions of the physical environment, enable mass personalization, and automate routine and dangerous works. Hence, they can improve the performance of industries. And while technologies have shown the potential to improve the performance of industries, the nature of the construction industry leads to a general resistance towards the adoption of new technologies, resulting in low technology adoption rates. At the same time, it is generally recognized that effective project management is critical for project success. However, there are limited studies on the impact of smart technologies on project management. Hence, this study aims to provide a better understanding of the smart technologies on project management. And to do so, this study has the following specific research objectives. Firstly, to investigate the smart technologies with the greatest impact on project management knowledge areas, assess the specific project management knowledge areas that will be significantly affected by the technologies, and to statistically analyze if organizations of different sizes perceive the impact differently. So some of the common smart technology applications in construction projects that may significantly impact project management include real-time monitoring and control of labor, materials, and equipment on-site and along the supply chain, integrated data platform for decision-making and optimized planning, real-time communication, automated construction processes, data collection, and contract execution. So these applications, they are expected to impact project management processes with the digitalization, automation, and integration of the entire value chain. So the smart technologies that were perceived to have the greatest impact on project management knowledge areas and the knowledge areas that were most impacted by the technologies will be further studied. And to achieve the objectives of this study, the following research approach has been undertaken. First, a literature review was conducted, followed by expert panel interviews to enrich the findings of the literature review and to validate the developed survey questionnaire. And the survey questionnaire was then distributed to the target respondents, with 73 valid responses received. The collected data is then analyzed using min rank analysis and Mann-Whitney U test and validated through post-survey interviews in step 4. And out of the 73 responses, about 70% of them are project managers, a quarter of them are architects, and about 7% of them are directors. And out of which, about 60% of them have more than 10 years of experience in the construction industries. And about 60% of the respondents, they represent small and medium enterprises. Next, we move on to the data analysis and discussion section. So based on the results, all smart technologies were found to impact project management knowledge areas, and the smart technologies with the greatest impact on project management knowledge areas were found to be autonomous vehicles and robotics, cyber-physical system and Internet of Things, and big data. So now we will take a look at autonomous vehicles and robotics. First, the top smart technologies with the greatest impact on project management knowledge areas were found to be autonomous vehicles and robotics. So this finding is expected as the construction industry is known to be a dirty, dangerous, and difficult industry, and autonomous vehicles and robotics, they can automate dangerous and routine works. In particular, project quality, schedule, and cost management were perceived to be most impacted by AV and robotics. This can be contributed by the improved consistency of works and reduction in human errors and enabling of more holistic monitoring of projects. The use of autonomous vehicles and robotics also shift the workload of planning into earlier project phases, resulting in changes to project quality, schedule, and cost management planning processes. And next, we will take a look at the CPS and IoT. And as these technologies are used to integrate the entire value chain, the fragmented nature of the construction industry may be overcome. In particular, project communication, stakeholder, and integration management were perceived to be most impacted by CPS and IoT. These may be contributed by the provision of access to the same updated project information to all stakeholders as required, and increased transparency along the supply chain. And finally, for big data, and as there's a high level of uncertainty during the planning processes and the reliance on the planner's past experience in the development of project schedule and cost estimation, big data can support decision-making through the analysis of historical and real-time data. And while big data provides decision-making support, project communication, stakeholder, and integration management were perceived to be most impacted by big data. This could be because big data is an enabling technology for CPS and IoT. In addition, as projects frequently face change requests, big data can be used to assess the impact of the change request on the project baseline. Furthermore, big data enhances data visualization, aiding in communications to stakeholders. Next, the perceived differences among different organization sizes were investigated. It was found that the impact of CPS, IoT, and big data on project integration management, AV and robotics on project quality management, and laser scanning on project schedule and quality management, they were perceived differently among organizations of different sizes. In particular, large enterprises perceive the impact to be greater than small and medium enterprises. This could be contributed by the tendency of SMEs to be more flexible in order to stay competitive, while large enterprises tend to have a reputation to uphold and may have standard operating procedures in place to ensure consistency of works. And with that, the study found that the smart technologies perceived to impact project management the most were autonomous vehicles and robotics, CPS and IoT, and big data, with all the project management knowledge areas perceived to be impacted by all the smart technologies. Organizations of different sizes also perceive differences in the impact of several smart technologies on project management knowledge areas. And to conclude, the findings of this study allow practitioners to anticipate the changes in project management processes, which can prepare and facilitate the digital transformation of the construction industry. And with that, this is the reference list, and thank you for your time.
Hello, my name.
Yeah, thank you for the presentation by Jasmine on the impact of smart technologies on project management and the survey based on Singapore. Any points to be raised or issues or questions? It seems that they looked at the impact of yes, Mohammed. Yes, please.
Thank you, Taha. I hope she hears the recording. It's a very interesting topic, and many researchers are interested in that. I think what would be interesting is to look at the qualitative data to understand why certain tools are favored in certain processes, certain aspects of project management rather than the other. Is it purely because of the technology itself, the maturity of the technology? Is it because they find it easier? Or is it related more to the business dynamics where certain areas they don't want the technology to be involved, they still want to handle it themselves? So it's interesting, but it's probably provides a platform for some interesting research.
Yeah, thank you, Mohammed, for the comment. I also want to make another comment, additional one, for them, for Jasmine and her colleagues, to look at the research work which had been going on for a number of years at Salford University by the Construct IT body there, which also developed some maps and frameworks for the different stages of the project and different aspects construction management and project management in relation to the technologies and the suitable and appropriate technologies for each one of them. So also this will make also a continuity of the research because now the advanced technologies as well need to be included and added to these type of studies. Thank you, and we are moving to the next presentation by Ashley Bashani, Majid Al-Hawari, and Yasmin Nilsson, and it's about assessing implementation of planning and scheduling in construction projects across India.
Hello everyone, I'm Ashley Bachani, currently working with ASGC Construction, and I would like to say thank you for giving us an opportunity to present our topic, assessing implementation of planning and scheduling in construction projects across India. And also, I'm grateful to my fellow authors, Mr. Majid Al-Hawari and Ms. Yasmin Nielsen. The contribution of the construction industry to India's GDP is approximately 9%. Indian construction industry is currently worth approximately $145 billion. The industry is growing at a compound annual growth rate of 15.9%. The market has shown great potential, as we can see from the numbers, but the industry is also facing delayed projects. This research focused on planning and scheduling challenges in 4 different construction terrains in India: the hilly region, the northern plains, the coastal region, and the desert region. Now, as we can see the map of India. We are going to categorize this map of India as per the regions in the previous slide. This is the desert region in the western part of India. These are the coastal region, which majorly comprise of areas which have access to the waters, but also comprise of minor hilly regions and plain area. This is the hilly region of India. And now we highlight the northern plains, which majorly comprises of plain area, so easy construction, but also comprises of small hilly regions and minor coastal region. Construction in these diverse regions face distinct challenges like different types of soil, variable climatic conditions, different building techniques, and logistic difficulties, which is majorly in the hilly region. Now the topic is planning and scheduling. So let's define what is planning. Planning is the determination and communication of a proposed course of action by integrating thorough methods by showing time, place, and the resources. Basically, it lists all the activities by areas and the strategy of execution. Scheduling means creating an order and logic and estimating the workforce by linking all the activities to each other and by highlighting the critical path or the key milestones on each project. A proper schedule leads to the most efficient and cost-effective project. Now let's highlight the research gap which was important for this research. 70% of infrastructure projects in India are facing either time or cost delays. It became worse due to the COVID-19 crisis, as 90% of the construction projects are facing delays now due to the lockdown. The main reason for delays are land acquisitions, inadequate planning, inappropriate budgeting, underestimation of project cost, changes in project scope, and shortage of workforce, among others. It has been observed in the literature that within the number of projects which are delayed, 51% of the delays are caused by the client, while 36% by the contractor and only 13% by the consultant. Industry research also highlights that among the projects which have a cost overrun, approximately 40% of these projects undergo more than 10% of change. Let's talk about one of the biggest examples, Bandra-Worli Sea Link. This beautiful bridge is in the financial capital of India, that's Mumbai. But it also highlights one of the major projects which faced a failure. The project was planned for approximately $45 million and to be completed in 2004. But eventually it got finished in 2009, which means a 5-year delay in time, while a 425% cost overrun and the actual completion of cost was approximately $237 million. Now, this delay can be due to multiple reasons, which can be inadequate workforce, improper experience of the team, availability of almost no technology to execute this kind of a project. It can have multiple reasons for the delays, but this was one of the major projects which got failed because of improper planning and scheduling and improper communication between the project team. Let's talk about barriers to project planning. It can be many, but few are highlighted as follows: inadequacy of the project management team, lack of communication between the stakeholders, poor site management, environmental clearances, acquisition of land, shortage of finances, and interdependencies on multiple government organizations for various approvals. Now, let's talk about barriers to project scheduling. Different perceptions of the project by multiple stakeholders, the commitment of the stakeholders, failure in coordination between time schedule and execution, intra-organization and inter-organization conflicts, which can be conflicts of opinion among the client or among the contractor or among the consultant, but also conflicts between contractor and the client, contractor and the consultant, client and the consultant, client and the contractor. It can have multiple variables to it, or unforeseeable risks like natural calamity. Now let's highlight the aims and objectives of this research. The aim is to inspect the significance of project stakeholders in understanding the application of planning and scheduling techniques in the construction industry of India. This aim is achieved through multiple objectives as follows: to identify various planning and scheduling techniques that are essential for proper project planning and scheduling, to recognize the barriers to project planning and scheduling, and to highlight the importance for successful project by highlighting planning and scheduling importance, and to analyze the significance of project managers in the construction industry across India. Now, the methodology adopted for this research. The researcher adopted an interpretivism epistemology, a study in which the researcher interacts with the research. The data was collected using both qualitative and quantitative approaches. The researcher conducted 12 semi-structured interviews as well as 50 questionnaires across 10 projects in different regions of India. The connection between the literature and the research adopted deductive and inductive approaches, as highlighted as follows. The finding and the results. Let's talk about the respondents' background. Through the interviews, the responses were majorly from the client, which is 4, project managers 3, contractor 3, and the architect or consultant 2. Even the questionnaires, we tried to cover all the stakeholders as highlighted in the pie chart. Years of experience. As we can see, more than 50% of the people have more than 15 years of experience, which shows the quality of data that has been gathered. And we have also covered all the topographies, and we have given equal importance to everything. Now, importance of planning. Almost 80% of the people believe planning is important for successful completion of a construction project. As well as for scheduling, more than 80% here also believe that scheduling is crucial for successful completion of a project on time and within budget. We can also see irregularities in WBS, work breakdown structure, can impact a project completion, as highlighted by almost 70% of the people. It has also been highlighted very clearly by almost 80% of the respondents that adequate float is crucial for successfully completing a project. If one activity gets delayed, it should not impact the overall completion of the project. Almost 80 to 90% of the people have highlighted that project manager and the skills of project manager are very crucial for successfully completing a construction project and for adequate project execution. The management techniques for a construction project which are widely used is critical path method by 56%, PERT by 20%, and Gantt chart by 16%. Teamwork and leadership are soft skills which are essential for proper communication among stakeholders and for managing a project. Majorly, the conclusion is as follows. The study concludes that all project stakeholders play a crucial role in determining the project's success and are equally vital for proper project execution of construction activities. The responses were in cohesion with the literature that planning and scheduling is crucial for a construction project. Each region of India faces barriers that can be mitigated by proper planning and scheduling, but the most challenging area to work is hilly area, followed by desert region, and is most visible in the northern plains. The challenges can be overcome by clearly defining scope, detailed resource allocation, localized procurement, and proper communication. At the same time, it also highlights that both planning and scheduling are a team effort that also involves all stakeholders. It is equally important for everyone to be a part of the research. The project manager drives through the knowledge and experience, and he is essential or she is essential for the construction in any construction environment. The research has aimed to inspect the significance of project stakeholders in understanding the importance of planning and scheduling in the construction projects of India. Thank you so much for giving us an opportunity to present our paper. Thank you.
Thank you, Ashley Bashani, for the presentation and sharing your research and findings on this also important issue of project planning and scheduling. I can't see Ashley Bashani in the room. And I don't think there is if there is anyone who's going to respond. I can't see. Are there any comments or points to be made for Ashley? I've got one point for Ashley, and hopefully they will listen to the recordings later. How about comparing? This issue has been also studied in different countries, in different regions of the world, with good findings and results also. It will be very good if they manage to compare their findings and outcomes with other previous literature outcomes and results, and try to come up with a conclusion on the differences and similarities which we expect in different areas, different countries in this topic. Any other comments or points? If not, then we can move to the next presentation. It's by Peter Haglund. It's on logistics strategy, structure and performance, a typology of logistics configuration in construction. Can we have it, Mohammed? Yes.
I'm a PhD student in construction logistics at Leeds Beckett University, and this is my presentation on the paper Logistics Strategy, Structure and Performance, a typology of logistics configurations in construction. Poor logistics management is discussed as one of several reasons for low productivity levels in construction. But during the last decade, there's been some development in terms of how new roles have emerged, and that has not existed before in the construction industry. So, for instance, it's not uncommon to find logistics coordinators and specialists in contractor companies. And another trend is also increasing use of third-party logistics providers who specialize in setting up logistics solutions in projects. So the outcomes of these new roles is improvements to certain areas in construction, So for instance, improved planning, reduce disturbances and improve productivity, and overall a better working environment on construction site. However, these are rarely developed at a strategic level, so they're characterized by being standalone solutions that lack a holistic view on logistics. So in general terms, previous logistics and supply chain management research highlight that we need to consider two aspects of building operations. And the first one is the characteristics of the product itself. And the second one is the operations of building production. Jonsson Rubel developed a production system classification matrix where the feasibility of a production system depends on the degree of product standardization. Likewise, a contractor's configuration of logistics strategy and structural elements need to align with the type of production system and degree of product standardization. So the purpose of this paper is to develop a typology of such ideal logistics configurations in construction. The paper is based on a critical review of mainly three literature areas, where the first one is configuration theory, which describes the underlying logic of logistics configurations. The second one is standalone logistics and operations management contingency studies, and the third one is empirical research of logistics management in construction. So the typology is then developed based on a synthesis of these three literature areas. Moving on to findings and results, the first step involved in developing the conceptual model was dividing configurations into the logistics context and the organization of logistics. And a match between their different aspects represents an ideal configuration, which is referred to here as profile fit. And profile fit means if the sample profile, the one that is observed, if it aligns or adheres to the ideal profile, then it's considered to have a high level of fit, which then is related to a certain level of performance in logistics outputs. And this in turn influences or contributes to the bottom line performance of a contractor's construction projects. So based on the conceptual model, two ideal profiles or ideal configurations were identified that are positioned at the extremes of a spectrum. So the first one here is the process-oriented configuration, which resembles the industrialized house builder. And they typically produce modules, volume modules in an offsite factory, and then assemble them on the site. So they have relatively few deliveries, few larger deliveries to the site, which makes planning and control easier. So their logistics organization can be centralized, where a dedicated team can manage module production from inbound material supply to the factory to delivery assembly on the construction site. And the second one here is the project-oriented, which resemble to general contractors. And they produce unique buildings that they assemble on a construction site, which leads that they have many and very small deliveries that need to be coordinated. So therefore, they need decentralized planning and control by, for instance, logistics specialists in the projects. So to sum up, first of all, by focusing on defining these ideal logistics configurations, they can be served or used as catalyst for increasing the pace of innovation, mainly in management and process innovation in construction. So new organizational forms in terms of management innovation and new ways of structuring work tasks and production in construction projects in terms of process innovation. So cross-sectional studies can be used here and can provide guidance for contractors of which potential logistics strategy components and how to structure logistics tasks. Longitudinal studies, on the other hand, are very important as well, and they serve a complementary role to cross-sectional studies. So, for instance, by opening the black box here of what is happening beyond the strategy and structural elements that are identified at a certain point of time. And these are very important, and to see how change actually happens and how organizational structures and strategies and new logistics processes form over time. And that was all for me. Thank you for listening.
Hello everyone, I'm Ashley Bachani, currently working with ASGC Construction. And I would like to say thank you for the opportunity to present our topic.
Can you stop this one, Mohammed?
Yes, sorry about that.
Yes, okay. Thank you very much for Peter Haglund for this really interesting links they trying to make here and the feeding from the configuration theory and management and systems to the logistic strategy and performance. I'm not sure if is Peter with us here?
Yes, I'm here.
Okay. Hi, Peter. Thank you very much for this really interesting points and ideas you are sharing with us here. Any questions or any points, please? Okay, let me start by saying you also pointed out a very good issue, which is the pace of innovation in process and management and the use of configuration management system to enhance that. Can you elaborate on this point, please?
Mainly it was, I don't really focus on innovation in itself in my research and in this paper, but I thought there was an interesting link to, since I use configuration theory in this paper, or based my paper on configuration theory, which is very focused on organizational structures and matching that to certain environmental characteristics. And I thought that since logistics is still emerging in construction, and I'm thinking about here in the Swedish context, we have a lot of new roles with, for instance, these third-party logistics providers and also the contractors' in-house logistics roles. And in some way you can use configuration theory as an underlying logic, how these should be structured based on, for instance, product and process characteristics. And that leads to the new ways of managing production and supply in construction projects. So that's the link to management into innovation.
Okay.
Yeah.
This is really good. Actually, configuration management and configuration systems and theory adopted for quite a long time in other sectors like aerospace industry or defense industry, and they developed the thinking behind configuration management. And recently we see that some studies and research as well as practice bringing it to the construction sector. And this is a good work you are doing here on the implementation or application of configuration management and theory into the logistic domain in the construction sector.
Yeah, thank you very much.
Right. Any other points or issues to look at? I think my third point here, I would like to just point out to you that how to benefit from the application of an adoption of configuration management in other sectors, and benefit from that into your study and your research. So if you can also have a bit of comparison or lessons learned from other sectors when they implement configuration management and bring that into the construction logistic issue here.
Yeah, I think I'm very much inspired by these studies in other sectors, because there are not, as I've seen at least, not that many researchers in construction management that adopt configuration theory, like ideal configurations and how you should, at least for logistics, and maybe they do it on a more, you could say, organizational level, and I'm thinking like contractor firms. But for construction logistics, it's still logistics in some way, and the same. It's still about material flows and information flows like it is in car manufacturing. But then you also have to consider the special, or not special, but the differences between car manufacturing and construction. Like you have a fixed site where all the materials converge to the site, and you also have to consider like temporary project organizations and such. So there are some differences that this configuration approach need to be adapted to work. And also what I mainly emphasize is the engineer to order type of production in construction compared to make to stock in other manufacturing industries. So that you also need to consider, because there are some differences there that are inherent that influence logistics.
Very good. Really good points you are raising here as well. Thank you very much for that.
Yeah, thank you.
Thank you. And now we move to the presentation by the work by Theo Hope and Mariam Akinlolo on client involvement and construction project healthy and safety performance. Till yesterday, we haven't received the presentation, but I'm not sure if the presentation arrived today, this morning, because there was some exchange of emails.
Yes, we had an email from one of the co-authors, and fortunately, the main author is in hospital. It's probably the time we're living in now. So she apologized that she couldn't make it because she's still in hospital and not well. So we don't have a presentation here, but the paper is in the proceedings.
Okay. We wish her speedy recovery, and we, in this case, we just point the attendees and those who are going to listen to the recording later to the paper. And if later we have the presentation, we will also upload it on the conference website. I'd like to thank all our presenters and the audience for these knowledge sharing and bouncing of ideas and discussions in this track. And I would like to ask if there are any comments or views you want to share. We have, I think, 4 or 5 minutes on our side. If there is no more points or comments to be made, I think we can bring this track and session to a close, and then we are going for the lunch break now, and after that we are going for the keynotes number 7 and 8 by Professor Chris Goss and Don Ward, the Chief Executive Officer of CIB. So we will go back to the morning meeting room and the opening meeting room, and we will take these keynotes there. So I wish you enjoyable lunch. There are time differences in different countries. It could be late lunch for us here. And thank you very much for you all. Thank you.
Thank you. Thank you, Ta.
Thank you.